Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today class we are going to discuss about 4-point IDFT using DAF algorithm. Inverse discrete Fourier transform using decimation in frequency algorithms. Look at this. Given problem is find IDFT for the sequence x of k equal to 0 to 0 to using DAF algorithm. So this is the given problem. Capital X of k will be equal to 0 to 0 2. Now we need to use the algorithm of DAF algorithm. Look at the structure. So a number of samples n equal to 4. So we have n by 2 butterflies in each stage. So number of stages will be 2 stages, and each stage it consists of 2 butterflies. And then input is natural order, output is bit reversal order. Look at this. This is x of 0, x of 1, x of 2 and x of 3. And then output side, this is x of 0, this is x of 2 and this is x of 1 and this is x of 3. So input is natural order, output is bit reversal order. So given problem 0 to 0 2. And then Twiddle factor, look at this. So we have first stage, we have 2 Twiddle factors. So first butterfly Twiddle factor is 1 and second butterfly Twiddle factor is minus j. That is W4 0 and this is W4 1. And second stage it consists of W04, so it will be 1. So for both butterfly this is W04 only. So both value will be equal to 1 only. Look at this. So now we can feed the inputs. So this is the natural order. Directly we can feed the inputs 0 to 0 2. Look at this. So inputs 0 to 0 2. So we can directly feed the all 4 inputs. Look at this first butterfly. So we have these 2 inputs as an input for this butterfly, and these 2 will be an output for the butterfly. So these 2, look at this. So here this is x of 0 and this is x of 2. Look at this. This is 0 and this is also 0 only. Now we can calculate this. So for an uplift, simply just add the 2 inputs. So here 0 and here also 0. So we can add this 0 plus 0, that will be equal to 0 here. So this is the first butterfly result. And then downleaf we can take this. So we have the values of 0 0. So 0 minus 0 and then multiply with the Twiddle factor. So this Twiddle factor is 1. So 0 plus or minus 0 will be 0 only, and multiply with 1 also, that will be 0. So for first this green butterfly, both outputs will be 0 and 0 only. Now look at for a second butterfly. So we have 2 inputs. So one input is T2 and another input is also 2. And then Twiddle factor is minus j. So upleaf, simply add the 2 inputs. Downleaf, subtract in and multiply with the Twiddle factor. So upleaf, look at this. So here 2, here also 2. So 2 plus 2 will be equal to 4. So this is for upleaf. So we get a 4 here. And then downleaf, look at this. So first we need to perform subtraction and then multiply with this Twiddle factor minus j. So 2 minus 2 into Twiddle factor minus j. So 2 minus 2 will be equal to 0. So 0 into minus j, again it will be 0. So first stage final outputs will be 0, 4, again 0, again 0. So this is the first stage output. Now come for a second stage. Second stage, both Twiddle factor will be 1 only. When the first butterfly, the input is 0 4. Second butterfly, both inputs are 0. Now we can calculate for the second stage. Look at this. This is 0 and this is 4. For uplift, simply add the 2 inputs. So 0 plus 4, that will be equal to 4. This is for upleaf. And downleaf, we need to perform this subtraction. After subtraction, we need to multiply with the Twiddle factor of 1. So 0 minus 4 into Twiddle factor 1. So 0 minus 4 will be equal to minus 4. So minus 4 into 1 will be equal to minus 4. So this is the value for a first butterfly downleaf. Now we come for a second butterfly. So second butterfly, 2 inputs will be 0 and Twiddle factor is 1. So now we can take these 2 inputs. So this is 0 and this is 0. Uplift, just simply add the 2 inputs. So 0 plus 0. So the results will be 0 here. And then downleaf, look at this. So this is 0 and this is 0 and the Twiddle factor is 1. So we need to perform subtraction. So 0 minus 0 and then multiply with the Twiddle factor 1. So 0 minus 0 will be 0 and multiply with the 1 also will be zeros. So this is the actual output here. Again, this is a bit reversal order. We need to take a natural order. So this is then what is it? Look at this. This is x of 0, here 4, x of 2, this will be minus 4, and x of 1, that will be 0, and x of 3, that will be 0. Now we need to rewrite in the proper order. So first we get this x of 0, so this is 4, and x of 1 will be 0, and then x of 2 will be minus 4, and then x of 3 will be 0. So we get 4, 0, minus 4 and 0. And we are now performing an IDFT. So what we need to do, we need to take a complex conjugate and then divide by an n. So here all the numbers are real numbers. So that's why even there is a complex conjugate, no results will be changes. Only thing we need to divide by 4. So if we divide by 4, what we get? So this 4, so we get a 1 and then 0 by 4 will be 0 only. So 1, 0, minus 4 we get a minus 1 and 0. So final answer will be x of n equal to 1, 0, minus 1 and 0. So this is the final output. So here look at this. So input is a real number, output also real number. That's why the complex conjugate will not changes any results. So actually for IDFT we need to take a complex conjugate and feed an input. Output side also again we need to take a complex conjugate and divide by n. So here both inputs and outputs will be in real numbers. That's why complex conjugate will not affect the results. Simply we get the actual results. So only thing we divide by n and take the results. Thank you.